Okay, in this video we're going to look at vector notation. Two ways that we can describe vectors, objects or values with magnitude and direction. So the first one is using the magnitude of the vector and the direction directly. This is similar to polar coordinates. So if you've done polar coordinates in math class where you have a distance and then the angle that that distance is at, this is what we're doing with the first way of notating it. This is the asteroids notation, right? Think back, you probably played that on a app at some point or similar to asteroids where you fly around the screen in your little spaceship, right? It looks something like this. And you can spin your spaceship around in different directions. So you aim it up here, and then so you turn, something like that, and then you shoot in that direction. So you have an angle and then the direction you shoot. We're going to call that r, right, related to our vector. So if my vector is 5 newtons, this is a unit for force. Don't confuse it with north. 5 newtons, so it's a force vector, at 36.87 degrees north of east. I can locate that vector by always starting at the center. I'm going to draw my coordinate system, start at my origin, and I'm going to locate the angle first. North of east means, I'm going to do a little grid. We usually use these as like positive y, positive x, negative x, but we can also use north, east, west, and south when giving directions like a compass. So if I'm north of east, that means I start east and I slide to the north, whatever that angle is. So this angle is north of east, 36.87 degrees. And the magnitude of the vector is relative to the length, which is 5 newtons. So that's one way I can represent this in the r theta representation of the length of the vector and the directly in that direction with the angle relative to the coordinate system. So think the polar coordinates or the asteroids notation. Now there's another one I can use, and that is the Pac-Man notation. And to list it as the Pac-Man notation, I'm going to define this vector as a combination of how far it is in the x-axis and how far it is in the y-axis. So, and I think I did this backwards. 4i plus 3j. I'll fix that now. I think I just noticed my mistake there. Okay, what is this? What is I and what are j? I and j is what we call unit vectors. And they're unit vectors in the x direction and the y direction. What they represent is a single vector in the x direction of magnitude 1. The j vector is a unit vector in the y direction, also of magnitude 1. So if I take a unit vector and I multiply it by a scalar here, the 3 or the 4, 4i would just mean 4 unit vectors of length 1. 1, 2, 3, 4. So this would be the vector 4 times the unit vector I. This is the scalar, this is the vector. Okay. 3j would be 3 vectors in the y direction, 3 unit vectors. So 3 is the scalar multiplied by the unit vector j. That represents this vector, that vector. Okay, so how would I rewrite this vector as 4i plus 3j? Well, this just says I go 4 unit vectors to the right in the x direction, positive x. And then from here, I go up 3 unit vectors j in the y direction. So this is my Pac-Man notation, right? Because when Pac-Man goes across the screen, right, he eats up his little pellets, and then he hits a corner, and what happens? he has to turn. Let's see if I can do this. And he goes this way and eats his pellets, right? So he goes to the right, or one direction, and turns 90 degrees to the other. So I go one direction, and the key there is I'm creating a 90-degree angle. So polar coordinates would be the 5 newtons at 36.87 degrees north of east. That's one way of representing this vector. And then the vector notation, I didn't write that down. This is vector notation. With 4 units in the I direction, which is x, plus 3 units in the j direction. This is also a way of representing the vector r. Okay, so those are our 2 notations. In the next unit, or next video, not unit, also in vectors, we're going to show you how we can convert back and forth using some well-known trig from one notation to the other.